All right, 8.3, we are going to start graphing general rational functions. If you look at the functions that are shown on this worksheet, you'll see that in the numerator we have a function as well as in the denominator. So we're going to be dealing with functions that take this form right here, where we say y, or we could say f of x, equals p of x over q of x. So we're going to have two separate functions, one in the numerator and one in the denominator. So this is going to make for some very different looking graphs. And so the way we're going to graph these is we've got to find three things before we can even start plotting points. And so you'll see here in step 1, we need to find the x-intercepts. In step 2, we need to find the vertical asymptotes. And then in step 3, we're going to find the horizontal asymptotes. After we've gone through and done all of that, which is a little more complicated with these general rational functions, then we'll go down to the step where we're going to plot points, step 4 here. So to find the x-intercepts, you're going to set the numerator equal to 0, and then you'll solve for x. So in number 1 over here, we'll set x squared plus 2x minus 15 equal to 0. And then we're going to solve for x. This is a simple, it's very factorable here. We can use factors of negative 15 that add to 2. So we'll end up with this, and then we'll have zeros at negative 5 and positive 3. So this is where your graph, if we were going to graph number 1, that's where the line, the two places of the line would cross the x-axis. So then we move to step 2, where we're going to find the vertical asymptotes. We'll do that by taking the denominator. In this case, x squared minus 36. We're going to set that equal to 0. And we're going to solve for x. So we'll end up with, x equals plus or minus the square root of 36, which I'm just going to go ahead and write in that 6 there. Okay, so here are your vertical asymptotes. So we have our x-intercepts, we have our vertical asymptotes. And then the last thing we have to do is find the horizontal asymptotes. This one is probably, it doesn't require as much work to do, but you have to keep all the different possibilities straight. So the way we're going to find where the horizontal asymptotes are is by looking at the degree of the numerator and the denominator and comparing them. So this means all of your terms need to be in descending order based on their exponent, which they are in number 1. The numerator and denominator are both aligned properly. And then we're going to compare the two of them, right? So in this particular problem, number 1, the degree is 2 in the numerator, right? So I'm getting that from this exponent here, and the degree is 2 in the denominator. So in this case, we have a scenario that looks like the second one down here. The numerator equals the denominator, then the horizontal asymptote is at y equals a over b. A and b, in this case, just refer to the lead coefficients. A is going to be the lead coefficient of the numerator, and b will be the lead coefficient in the denominator. So for number 1, the lead coefficients are both 1. 1 in the numerator, 1 in the denominator. So that means our horizontal asymptote is 1 over 1, which is just going to reduce down to 1. And that would be at y. I mean, it's a horizontal asymptote, so that hopefully will make some sense to you. If we're going horizontally, we're going to be at a y. And this would be the line at y equals 1. All right, if we had number 2, we're going to have the same scenario where our degrees equal each other. The numerator and the denominator are both of degree 2. So that will take the same form as this number 1. Number 3, we have a different scenario. The numerator has a degree of 1, while the denominator has a degree of 2. And so that falls into the scenario, the third scenario that I have listed here. The numerator, and remember, we're talking about the degree on the numerator. We're not talking about whether the numerator itself is less than the denominator, which, we can't even tell that from this form. But keep that in mind. We're talking about the degree. So in this number 3, the numerator is less than the denominator, so then the horizontal asymptote is a y equals 0. Up here in scenario 1, if the numerator were greater than the denominator, then there is no horizontal asymptote. Okay, so those are the 3 possibilities. Like I said, there's not much algebra to do to find the horizontal asymptote, but you've got to be able to keep those scenarios straight. All right, so number 2, we'll find our x-intercepts by setting the numerator equal to 0 and factoring. All right, we're going to end up with 2x minus 1s, 2 binomials that are both x minus 1. They'll both solve out to give us a 0 at 1, so that's our y-intercept, our only y-intercept. I'm sorry, I said y, I meant x. X-intercept. We'll set the denominator equal to 0 to find our vertical asymptotes. All right, and in this case, we're going to end up with x equals plus or minus the square root of 2. We're not going to be able to graph the square root of 2, so we need to pull out our calculators and see what that actually is equivalent to. And we'll find that when we put in the square root of 2, we'll end up with plus or minus 1.41. So these are our vertical asymptotes. And then comparing the degrees, so we're looking for horizontal asymptote now. Our degree in the numerator is 2, degree in the denominator is 2. And so when they are equal to each other, we'll find our horizontal asymptote at y equals a, which is going to be this 1, this lead coefficient of 1 right here, over b, which is the lead coefficient of 1 that's in that denominator. So once again, we get another vertical asymptote, I'm sorry, horizontal asymptote at y equals 1, just like we did in the previous problem. All right, number 3 is a little bit different. The x-intercept, again, though, will be found by setting the numerator equal to 0. And we'll end up with x of 1/2 when we do that algebra. So there's our x-intercept. Y of vertical asymptotes with setting the denominator equal to 0. Now when we do this, we end up with x squared equals -7. We know that we can't have, this is going to be an imaginary number if we were to solve for this, right? Because we've got this negative here. If we take the square root of both sides, we're going to end up with the square root of a negative number. So because we would be dealing with imaginary numbers here, and we're not interested in that when we're graphing these functions, then we would say there are no vertical asymptotes in this particular problem. Horizontal asymptote, we're going to compare the degrees. Again, the degree in the numerator is 1, the degree in the denominator is 2, so that falls into this last scenario here. If the degree in the numerator is less than the degree in the denominator, then we do absolutely no calculating because the horizontal asymptote will be at y equals 0. Now let's actually move down and graph number 4. So we'll find our x-intercepts at wherever 2x plus 4 equals 0, since that's our numerator. All right, so we'll have one x-intercept at x of -2. So I'm going to go ahead and put that in. Then we'll find the vertical asymptotes at x squared minus 16 equals 0. So those, we're going to have 2 of those then. We'll have one at +4 and one at -4. So I'm going to dot those in. And then for the horizontal asymptote, we can see that the degree in our numerator is 1, the degree in our denominator is 2. So it falls into the third scenario over here where our horizontal asymptote is going to be at y equals 0. So that, I'll just dot in over top of the x-axis. Now we do have a point right there on that horizontal asymptote that the horizontal asymptotes are a little more fluid than the vertical. The vertical asymptotes you will not ever have, they'll never be crossed, the verticals. The horizontal can at times, depending on the function, be crossed. So don't be alarmed or surprised if you do end up plotting points. You're going to see here when we plot points to fill in this middle section here where the graph is going to go, we actually are going to cross over the x-axis and that horizontal asymptote. I mean, we have an x-intercept sitting right on that horizontal asymptote. So you'll see how this kind of works out when we start plotting some of these. So now we're going to go down to step 4, where we want to plot points left and right of the vertical asymptote. And so we'll make an XY table. It's going to be a little larger than it has been in the past because we have 2 vertical asymptotes that we need to make sure we know what's going on both sides of those vertical asymptotes. So now I'm just going to evaluate in a few points. I'm going to start with 0. And if I can do that in my head, I'm just, plugging in, evaluating 0 in the numerator and the denominator. Don't forget to put whatever you're plugging in to the table for x, it needs to go in both the numerator and denominator spots for x. So when I do that, I'm going to end up with -1/4. And when I plot that at 0, -1/4, it's going to be about right here. Okay, and so I can kind of see here that I'm probably going to have like a curved line that comes down that kind of looks like one of our cubed functions. If you need more points to actually be able to see that, you could just continue to plot a couple of more points a little bit closer to those asymptotes, and then you can get a better idea of the curve that this is taking. But I'm going to use just the x-intercept in that first point there that I just plugged in. And then if I plug in 6 now, so 6 will put me to the right side of this vertical asymptote so that I can see kind of what's going on that side. If I plug 6 into the function, I'm going to get 4/5 out, so almost 1. So that will put me about right here. And then I'm actually going to plug in 5 as well. That'll pull me a little closer to the asymptote, and I can make sure, I'm pretty sure it's going to kind of curve with that asymptote, but just to make sure, when I plug in 5, I end up with like 1 and 5/9, so just about like 1.5. And so that is getting closer to that too. We can definitely see that it's trending upward. And so when I put the curve in on those, it'll look something like this. The only asymptote left then is this one over here on the left at -4. And so I'm going to do the same numbers, just the negative versions. -6 will give me -0.4, and -5 will give me -0.67. So I've done all this with my calculator ahead of time just to save time. I'm not doing those, obviously, in my head. So -5.67 and -0.4 are going to be just about like that. And then, so this section will curve around like that. So you can see how this graph is for sure following those vertical asymptotes. And then the ones over here in the corner are using both the vertical and the horizontal, which is pretty typical of what you'll see in these functions. The middle section is generally the one that might cross over the horizontal asymptote in some functions. All right, number 6, x-intercepts. Will be at plus or minus the square root of 3. Obviously, you put that into your calculator, and you'll get plus or minus 1.73, so about 1 3/4 on both sides of the x-axis. So I'll go ahead and put those in. So we've got one there and one about here. The vertical asymptotes are at the denominator set equal to 0. Now this one's going to be a little more complicated to factor, not quite as easy as the ones that we have done previous to this because our lead coefficient is not 1. So we've got a 2 here. I can't factor the 2 out. It's not the GCF on all 3 of these terms. So this is when I have to go to multiply the numerator, I'm sorry, not the numerator, the lead coefficient and the constant together, so the 2 and the negative 12, which will give me negative 24. And so now I'm looking for factors of negative 24 that will add to 5. So that would be 8 and negative 3 will work. Then I'm going to rewrite that 5 as a function of, as a sum rather, of 8x and negative 3x. And then just keep my first and last terms the same. This is when I group off, group these two and these two together, and then factor out the GCF of each. And our binomials match, so that's a good sign. We'll pull out that binomial. And so now we have it factored. We'll just set each of those equal to 0 to give us our zeros. So a little bit more work on this one, but our x-intercepts end up, our vertical asymptotes are at negative 4 and positive 1.5. So those are graphed in orange now. I'm going to kind of enlarge this graph a little bit more. And so you can see our vertical asymptote here at 1.5 is getting really close to the x-intercept at positive 1.73, but it's not touching, so we're okay. It's not crossing that vertical asymptote. So the next thing we need to do then is find our horizontal asymptote, which are the degrees of our numerator and denominator match. They're both second degree. So that means we're going to put the coefficient of the numerator, the lead coefficient, which is 1, over the lead coefficient of the denominator, which is 2, in order to get our horizontal asymptote. So that horizontal asymptote will be at y equals 1/2. All right, so then we'll move to step 4, which is our table. And I already have a point inside. I'm going to start with this middle section in between these two vertical asymptotes. So remember, that's what we're making. We're allowing those vertical asymptotes to guide the points we pick for our table. And so I'm going to start in that middle section. I already have one point with that x-intercept there. And so I'm going to get another point in here. And I'm going to pick 0 to do that, because 0 actually is falling inside this those two vertical asymptotes. So when I put 0 in to the function and I use my calculator, I'm going to get 0.25. So that'll be about right here. And I'm still not quite sure exactly what this is doing, so I'm going to go ahead and pick a number over here as well. I'm going to go ahead and put in -3, which will fall right here to the right of that vertical asymptote. And when I put -3 in, I'll get -0.67. So -3 and then -0.67 will be about right here. So now I can clearly, or maybe not clearly, but more clearly see that my graph is going to take on that shape, similar to the one previously in number 4. Then we're going to go to the left and right of these other, these vertical asymptotes. I'm going to go to the right and pull a number over there. So I already have one point right here with that x-intercept, the one that's really close to both the asymptotes here, but it's not touching them, so we're okay. I'm going to pick 4 just to get a little bit further away from that vertical asymptote. And I'll see that when I evaluate that in, I get 0.325. So that's a positive 0.325, not quite a half. So it's definitely going to keep me under this asymptote here, but it's getting really close. So we're about right here. So you can see that this is going to kind of be a graph that sort of curves down, and that's not a very good curve. But it's going to follow those asymptotes pretty well. So it's going to be pretty tight in there, but it's still going to take that curved shape like we've seen in the previous graphs. Then I'm going to go to the left side of this asymptote over here, and I'm going to evaluate at -6 as well as -8. I'll get 1.1 and 0.8 over here as well, and those again are going to be sitting pretty close to the asymptotes here at this point, and down a little bit closer here. So these are going to be following those 2 points as well as that asymptote there. So not too bad if you stick with the rules, but they definitely look a little crazy, these rational functions, when you graph them. So just stick with the rules and pay close attention when you're plugging in your values and graphing them out. I want to look at number 7 as well because it's a little bit different than the other ones. So I want you to see that they're not always going to look like 4 and 6 look here. In number 7, we will find our x-intercepts first, and that would be at x squared equals 25, so we're going to have x-intercepts at positive and negative 5, and they have numbered by 4s, which is going to make this a little bit more challenging, but there's our x-intercepts. Our vertical asymptote is going to be at x equals 4. I mean, I don't even need to do any work there. I can see that my denominator, set equal to 0, is going to give me a vertical asymptote at x of 4. So dot that in. And then my horizontal asymptote, I have a degree in the numerator of 2, degree in the denominator of 1. This is that first scenario that we haven't seen yet on a graph, where the numerator is greater than the denominator, so there is no horizontal asymptote, which is why this one is going to look a little bit different than the others. So no horizontal asymptote on this one. All right, so our table, we only have one asymptote here, just one vertical asymptote, so this makes it a little bit easier to plug in some numbers. I'm of course going to pick 0 because it's always easy to do in your head. I mean, so that's going to give me 6 1/4. 0 and 6 1/4 is going to be about right here. So I can see the curve on this one. And then x of 6 evaluated in is going to give me 5 1/2. So that'll be about here. And I can see the curve is going this direction. So if I'm going to follow the asymptote and the points, it's going to have to curve this way. So this one looks a little bit different than the ones we've seen in the past. But the same rules apply, and just be careful when you're, when you're plugging in those x, y values.